let's refresh that, and now notice how they've turned blue, and clicking it actually takes us to the right place. Clicking this one takes us to something that has no content. Alright, so that's how you would display the list of posts, and now we're going to work on being able to click this and show that there are no posts, but we're going to do that in the very next video. So I'll see you there. Hi and welcome back. So we've clicked our second blog, but it has no posts, and we want to be able to show that there are no posts. It's not that the page hasn't loaded properly or anything like that. So what to do is go into PyCharm and then find the posts.html file. And notice how here we're doing for post in posts. And this is going to iterate or go over all of the posts in our posts list. But what if there aren't any? Well, here's where the if statement comes in handy, and Jinja has that built in. So if posts vertical line length greater than 0, else end if. So here's what's happening. If the post's length is greater than 0, then we're going to go through the posts and write them out. And if it isn't, it probably means it's exactly 0, then we have to do something else. And what we have to do is simply say h4, there aren't any posts yet. Alright, so let's refresh, and you can see that there aren't any posts yet. However, if we go back to blogs and click on this one, our blog still appears there. Excellent. So that's how easy it is to create an if statement using Jinja. Simply use the opening curly brace and percentage, then if your conditional, close them. You can use an else, or you can use something else. Sorry, you can use the else, or you can not use it. And finally, the end if is required. So if we didn't have an else, we would simply write end if here. And that's how easy it is. And it's actually very useful, especially for this sort of things. Alright, so let's move on and see if we can create some blogs and some posts. I'll see you in the next video. Hi and welcome back. So let's try to create a blog. One of the things to realize when we're creating a blog is that only the currently logged in user is going to be creating a blog. So we don't need the user ID for anything in the root. So in order to create a new root for the blog creation, it is very simple. We simply say blogs new, for example. And then we define the method. And here is what's going to happen when this endpoint gets reached. And really what's going to happen is one of two things. If the endpoint gets reached with some data, or if the endpoint gets reached with no data. So I'm going to do this. I'm going to allow this endpoint to have two methods, either post or get. And remember that the user will only be able to access this endpoint with one of the two. And in fact, the user won't really know what endpoint we're accessing. Let's remember that as well. So if the method is post, I'm going to assume that the user pressed the submit button in the form. If the endpoint is get, the user just arrived at the endpoint. So when the user just arrives at the endpoint, I want to present them with a way to write the new blog details. And when the user sends me data, I want to actually create the blog. So the way to do that is fairly simple. Simply use an if statement. If request.method is get, else do something else. So if the request method is get, I want to return render template, where the template is going to be new blog.html. And if the request method is post, then I want to accept the data that has been sent to this endpoint and then create the new post. So how do we accept data? Quite simple. Title is request.form title. Content is request.form content. And that is it. Sorry, instead of content, this is actually description for a blog. I nearly forgot that. And blogs only have title and description. Let's go into the blog model and make sure that that is the case. So title and description is everything. And then they've also got an author. And the author, which is not the same as the author ID, has also to be shown there. So the author is simply the current user. So we get by email, session email, and then we say the user email is simply user email, so we don't need to do that. Okay, so now we've got the user as well. And then what we do is simply create a new blog. Blog, or rather new blog equals blog. And here we have to write the author, user.email, or user.name if the user had a name associated with them. Then title, description, user._ID, and that's it. And the last thing is the _ID for the blog itself, but that gets created automatically. So we don't have to worry about that. I'm going to go into the user model and just check real quick that we aren't missing anything here. And indeed, it seems that everything is fine. So I just wanted to check that we aren't missing any details such as the name or anything like that. But indeed, users don't have a name just now. That could be something that we could fix. And so the author is going to be the user.email for now. Okay, so that's how we create the new blog. And then we simply say new blog save to Mongo. And then we return render template, the user blogs, where blogs is that. So that is an interesting aside. How would we simply return that? And the answer is actually we want to return not just a page that says you've created your blog, but we want to redirect the user to his blogs. And in order to do that, we are going to need to redirect the user to this function. So how do we do that? And let's have a wee look. So instead of returning the render template function, we're going to return a make response function. And this make response function, the only thing it takes is user blogs. And of course, it takes the user._ID. So in our case, this will be the current user because we've got to that with the session email. But if we were looking at somebody else, then we could also return somebody else's blog. So for example, this could be useful if we were writing a blog for somebody else as a co-author. So that functionality is obviously not in our application just yet, but it could be in the future. So make response essentially calculates what this would return and then puts it here. And that is the function that we are calling. Okay, so let's have a look and see what happens when we access blogs new. So right now we need to create the template first, of course. So let's go and create the new blog. And I'm going to actually copy everything from register. Only that I'm going to change essentially everything. We're removing the class page form from there. The form is going to stay, but is going to be having an ID called new blog. The action is going to be blogs/new, and the method is going to stay as post. So this form, when we press submit, is going to send a post request to this URL, which in turn is going to say, is request method get? No, it's post. That's what the form sends, and then it's going to send the create the new blog. If the user accesses the URL directly, that's going to be a get request. So we're going to render the template. Okay, and then we need, instead of a label for email, we need a label for title. Notice how it goes red because we don't have a title ID there. Okay, and then instead of label for password, is going to be a label for description. And then we need to do that here. And this has to be text as well, of course. And then instead of sign up, we can use something better like create blog, for example. Okay, so now we've got all the different parts of our application there. Let's see what happens when we go into blog/new. So we get a form. Okay, my blog. This is a web blog. And create blog. And there we have it. Hurrah! So that worked. And now we've got my 3 blogs here. Notice, however, we're still in blogs new. So that is an interesting one. If we refresh the page, we may or may not create another blog. So let's see what happens. Notice that that created it again. However, if we press enter, we go back into the form. So maybe we weren't doing things exactly the way we should be doing them. But that is something that I'll let you investigate if you want to do that. Or if not, we'll be looking at that later on in the course, of course. So, nevertheless, it does do what we wanted it to do. So, the next thing is to create posts. So, we're going to do that in the very next video, and it's going to be pretty much exactly the same. So, I'll see you there. Okay, so in this video, let's look at creating new posts. It's going to be fairly simple, and the first thing we're going to do is modify the new blog code. So I'm going to paste that in here, and I do remember saying that copying and pasting code is oftentimes a sign that something has gone wrong elsewhere, the fact that you have to do that. And we could probably simplify the creation process in terms of code, but we're not going to worry about that in this section, and we're going to worry about that later on in the course as we progress further. So right now we're only worried about getting things to work, and once they do, we can improve them. So let's rename some things, posts new, and then instead of new blog template, it's going to be new post template. Instead of description, it's going to be content. And the user is still going to be the email. This is going to change to post. And the parameters are blog ID, title, content, author, and created date. So blog ID, title, content, author. And the date is going to be today's date. So author is user.email. And we don't have a blog ID. So what we're going to do is send the blog ID over here. Okay, so in order to create the new post, we are going to need the blog ID so we can access the page, which means that this link will only be accessible from somewhere where we have access to that blog ID. So in order to be able to access this link here, the user is going to need a button or a link to press to get to this new post page. And that link or button is going to have to be in the blog page. So if we go to user blogs, and in fact, if we go to posts.html instead, you'll see that here we are displaying the blog's posts. So what I'm going to do is also, at the very bottom, create, or in fact here below the title, create a new link that will allow users to write new posts. Button, class, btn primary. And this button is going to have a text like new post. And inside it, we're going to have an anchor, as we know, which is going to be /posts/new/blog ID. So let me explain really what happened here, what we've done and why we've done it that way. So in the blog page, we're going to display the title, and under it, we're going to display a button, with class button primary, which is the blue one, that button is going to have an anchor that is going to reference the post's new /blog ID page, and then that's going to have the new post text inside it. So when we press the button, we will go to this link here, which is the new post for this specific blog. But of course, this template does not have access to blog_ID, so we're going to have to change that and ensure that posts.html does have the blog ID. Like so. Okay, so now that template is actually going to redirect us to the appropriate place when we press the button. Now, we need to make sure that things are working here in the new post. The first thing to do, of course, will be to change the method name to create new post, and then to have this blog ID parameter here coming from the URL, and now we can use it to create a new post. Rename new blog to new post. And then the make response will actually not be user blogs. We're not going to redirect the user back to his blogs, but instead we're going to redirect them to the blog posts. Okay, so a few changes here. Nothing too massive. And let's see what happens when we actually access the page here. So the first thing actually to remember is that the new post template has to be created, and also it will need access to the blog ID. Why will it need access to the blog ID? Because in order to access the appropriate page and put the post in the correct blog, it's going to need to send us to this link here that has a blog ID in it. Okay, let's create the template, and that way everything will actually be clearer. So new post.html, copy everything from new blog, and now we're going to rename some things. Instead of new blog, it's going to be new post. Instead of blogs new, it's going to be posts new. And title, it will stay the same. Description will change to content. And that's it. Instead of create blog, we'll change that to publish. And of course, instead of posts new as the action, it's going to be posts new blog ID. So that is going to direct us to the appropriate page as per this route here. Notice that that blog ID is then going to allow us to link this post to the appropriate blog in which it belongs. Okay, so if we press play and then we go over here into our blogs, we've got the blogs. We're going to go into the first one. We've got the new post here. It doesn't look very good, and that's because the color of the button is actually the same color as the link text. So a quick fix for that will actually be to put the anchor outside of the button, and that way we can see it. And now when we press on that, it takes us to the correct place. This is not a very good editor, of course. And we can change that, and we press publish, and here we are back over at the correct place. So new post, another post, and there we go. Okay, so this is how we would create new posts. And the last thing to do is, of course, change this content. So this is right now a text field, which is only one line high. We want to change that over to a text area. And this text area will allow us to essentially have more lines. So now that's a bit longer. It can be resized. And there is a way to change the number of rows and the number of columns in this text area. But I've actually can't really remember off the top of my head how to do that. So that is a challenge for you guys. How would you ensure that this text area is initialized with being taller, essentially, having a larger number of rows? So you can find that out. It will be quite simple to do, but it's not essential to make this work. So what we've got now is actually a working thing. We are now able to create our blogs and create our posts, register, log in, and do all sorts of things. So there are a few more things that we could add, such as the ability to search for other users. by email, for example, and look at their blogs. We could add something like user profiles and have like names and surnames and biographies and things like that. There's a lot of things we could do, and indeed I encourage you to attempt to do that, because I think you now have the skills to develop this further into something that actually interests you, other than simply microblogs that don't have a lot to say. You can actually change this into something more interesting. But do play with it a bit, and then when you're ready to continue, then do move on into the next section. So thanks for joining me, and I'll see you in the next one.
Hi and welcome back. So in this video, we're just going to talk quickly about some of the things that we did in the last section that may have been improvable. Let's leave it at that. And also what we're going to be doing in this section. So a couple of things that we did in the last section that we did because we were concerned with making something that worked, as opposed to making something that was ready to release to thousands or millions of people. So what we did is we, for example, used a secret key that was hard-coded in our file. We simply defined it here, and that's not very safe. Ideally, for example, we'd want to generate it randomly every time the application starts. That's simply safer. Other things, we've got an app.py that is massive, and that will only grow as our application grows, and eventually searching through and finding what we want to edit in this app.py file becomes extremely cumbersome. Trust me, I've been there, and I know that I would not recommend it to anybody. Something else is that our templates are simply in the templates folder, and when we've got 20 or 50 or 100 templates, this gets really messy really quickly. So that's something that we would also want to avoid, and that we will avoid in the next section. So these are a few things that went wrong, and these are a few things that we are going to be correcting in this section and making sure that we are learning about development in sequential steps. In the last section, we were concerned about introducing the concepts and being able to start developing a web application that uses Bootstrap and everything that you need in order to get started. And in this section, we're going to be developing a much more complete solution and a much more growth-friendly solution that will be able to scale. And that's a key word in the industry nowadays. Be able to scale and easily grow to thousands or tens of thousands or hundreds of thousands of users easily. So that's what we're going to be doing in this section. And the project is going to be a pricing system. So users are going to be able to define their own department stores or online shopping websites that they are interested in, and then they're also going to be able to define items that they want to set price alerts for. So for example, they may go on a website and say, for this item, I want to be notified when it goes under $50. And then they would get sent an email once that price gets reached. So that's what we're going to be making, and we're going to be making it in a very general way, so that adding stores is very easy, adding website is very easy, adding items is very easy, and users can register and log in and everything. But of course, it's going to be a much more complete project than in the last section. It's also going to be a bit longer as well, and overall, it's going to be a great learning experience. So that's all, and I'll be seeing you in the very next video.
So one of the things we discovered in the last video regarding the previous section is the way that we structured our app.py was not optimal. When our application grows, the app.py would become so huge that it would be very difficult to find what we're looking for and to modify the appropriate things. It would simply become time-consuming. So Flask has this concept of blueprints, and here we can see the Flask documentation, which tells us what a blueprint is and how we can use it. Essentially, let me tell you, a blueprint is simply, in the simplest terms, a set of routes that can be put in a different file and then registered in the main application. So it's a way to split out your app.py into more modular files. However, they also do some other stuff, which is part of the strength of these blueprints. So for example, in this example, we are registering a simple blueprint called simple page that has its own template folder here. And then instead of at app.root, we do at simplepage.root. And then we can give it the roots just as we would normally with our Flask app. Finally, down here, we can come down and say app.registerBlueprint. And this is the blueprint's name as we created it up here. Now, these blueprints, as we can see here, simply register new endpoints in the app. However, one of the interesting parts as well is that we can register blueprints and give them a URL prefix, which means that instead of like root page or root only, we can now say root pages slash page or root pages. So it gives us some flexibility because we can define new endpoints in a modular way, put them in a different file which makes it more readable, and also very easily give them a URL prefix. So for example, we could make one for our users and say it would be /users/ whatever it is that our endpoint is. So blueprints is something we're going to be using throughout this section because it is indeed a very important part of Flask in order to make the apps readable. So I'll see you in the next video. So I've created a new project here and I've called it Price of Chair Web because we're going to be creating a web application that will allow us to track changes in items prices and notify us when they do change. So such a service already exists for Amazon, for example, and it's called Camel Camel Camel, and we're going to make something fairly similar. So the first thing to do is to think about the project structure. And it's going to be reasonably similar to the last section's project, but slightly more extended. And I'm going to simply go through and create a simple structure for us, and then in the next video we're going to look at the different objects and classes that we're going to be using. So we're going to need an app.py file still, but it's no longer going to contain all of our endpoints. We're actually going to need a source folder here, and the app.py is going to go inside it, so simply drag it in. And outside of the source folder, we're going to have our requirements.txt. Okay, in our requirements, we're going to have our Flask. We're going to have PyMongo. We're going to have beauty, if I can spell, soup 4, 4.4.1, and then we go into our app and it tells us to install them. We can do that already. We're also going to have another file in the source folder called run. And this is actually the file that's going to run our application. We're no longer going to do that through the app.py. It looks quite ugly having the if name equals main, then run the app, and if not, don't run it. We're going to have a file called run just to do that. We're also going to have another file called config, which is going to store the configuration properties, at least some of the basic ones for our application. And this is going to be modified by whoever is deploying the application on their own servers. We're also going to have, of course, a common directory, which is going to contain our database, and another file called utils. Stands for utilities. This is going to do things shared amongst all of the models and everything. For example, check if an email has a valid structure and things like that. And another Python package called models, which has a number of other Python packages, one of which is going to be users. And we're going to look at what other packages we're going to need in the next video, as I mentioned before. And each of these models is going to have a file, which is the actual model itself, i.e. what is a user, what does it look like to Python. It's going to have another file called views, and this views file is going to be this blueprint that we talked about in the last video. Essentially, what endpoints in our application are associated to these users. For example, login, register, profile, things like that. It's going to have, not a package, it's going to have another file called decorators, and we're going to learn what decorators are. They're extremely powerful Python constructs. And it's going to have a constants file as well. So you can put the constants inside the user model if you want, but having them outside means that they are more easily shared amongst the different classes, different files that make up this user model as a whole. So the decorators and the views might also use the constants. However, we're not going to have many constants, if any, in fact, in this model. It's simply to show you what this structure, this file structure for each of the models looks like. So with this, we're actually going to go into looking at what the user flow is going to be, and therefore what sort of classes and models we're going to need in our application. So I'll see you in the next video. Hi and welcome back. So in this video we're going to have a look at exactly what our application is providing our users. It's important to understand that our application is only going to do one thing, and it's not going to be a very large application. So therefore, we can simplify the entire application into hopefully one phrase. It may be a slightly long phrase, but it will really make us understand what the application is going to do. So here's what I've come up with for this application. We're going to get the price of an item in a store for a user with a price limit. So we're going to get the price of an item in such store for a user under a price limit. Let me write that down. Get the price of an item in a web store, really, for a user under a price limit. This is what our application does. So we've got items which have a price, we've got web stores, we've got users, and we've got a price limit. So we need a way to associate these things together. So let's think of the flow of the program. What does the user do first? The user creates an alert and gives us an email, gives us a price and item, URL, and then we check the price, and then if the price is under the limit, we notify them, the user, through email. Okay, so they'll go onto the website, create an alert, gives us their email and a price and the item URL that we were checking. We're going to know how to check the price for that item somehow, and that's what we have to figure out. And then we're going to check the price of the item, and if the price is under the limit, we're going to notify the user through the email, and we are going to repeat every 10 minutes, for example, or every X minutes. Okay, so now we've got the user flow. We need to figure out the program flow. How is that going to go? What is this email, the price, and the item URL? So the first thing we came up with is the user creates an alert. So we've got an alert. And the alert contains this email, contains this price limit, contains this item URL. Okay, so we've got that. We've also got a web store, which could potentially contain information like how to check items' prices. We aren't sure how we're going to do that just yet, but we know that we've managed in section 2, so there must be a way that we can maybe store this procedure of checking items' prices somewhere in the database. We're going to have users, which will contain emails for notifications, possibly a name, password, username. We're not sure yet. Do we even need usernames and things like that? Maybe not. Okay, so I like this. We've got 3 models, but one of them, this item URL, that feels to me like the URL belongs to the item, and the item has things like the item's price and the item's name, things like that. So I think item should be a separate model. So I'm going to do that. I'm going to have item, and item has a name, it has a price that we load from the website. It has a URL associated. And that might be it. So now the alert is no longer going to be an item URL, but it's going to be an item which is loaded or created with the URL. Okay, so here we have our 4 models. We've got our user flow, and I've got a whiteboard beside me in this room, so normally I would write these things down on the whiteboard or on a sheet of paper. This is essentially the first time using this program, so excuse me for the slowness, but we've got these 4 models: alert, a web store, which can simply really be a store, because our application is on the web. It's not going to deal with physical stores, evidently. We've got users, and we may or may not need names and passwords. We can decide that later on. And we've got the items. So if the users had names and passwords or usernames, then they'd be able to log in and change their alerts. So that could be an interesting proposal. So I'd say we go with that. However, if you're developing this application, you may want to skip that or do whatever you want, essentially. This is only a guide for what you might want to do, but of course you're free to change that. Okay, so now let's move on to the next video. Now that we've got the flow of the program, how it's going to work, the users and the models that the program is going to contain, we can go back, create those model structures, and start developing. So I'll see you in the next video. Hi and welcome back. So in this video, let's quickly initialize our application and create our application structure. So go into your models and create the 3 different models that we've come up with, which is the alert. And notice how we call the other one users. And I think that makes more sense because this model really encompasses all of the users. And then when we instantiate a user object, that's only one specific user. So we're going to rename that into alerts. Create your other model called stores. And finally, one last model called items. Okay, each one of these is going to have a view, or rather views file, and each one of them is going to have its own model file. What about constants and decorators? Are these going to have any decorators? And the answer is actually no. At least not for now, not that we've come across, not that I've thought of, but it has the potential to have decorators later on, but it is unlikely. So we're going to leave the decorators out for now, just so we don't clutter our view here. And are they going to have constants? And the answer is maybe. But we aren't really sure what constants they're going to have just yet. It is possible that they'll have constants, and we are going to think about those constants as we develop and possibly add those files in. Decorators, probably not. Constants, possibly, but we'll think of them later. Okay, so then let's go into our app.py, and we can do the usual from Flask, import Flask, and then say that our app is Flask __name __, and define our first root, app root, and say nothing, and then define our wee method that returns hello world. And normally now we would say if name equals main, then we would say app.run, and we would say debug is true, so that we get our errors out in the browser. It's easier to find out what's going on. And the port, which I'm going to set to 4490, because now I've got something running in 4495 as well. So, okay, this is what we would do before, but now that we've got our run.py file, we no longer need to do that. In fact, we can cut that, remove all of that, go into a run.py file, and what we're going to do here is simply import from src.app import app, and then say app.run. So this file is actually what's going to be running the application. The app.py now stores what the name says. The app.py now stores the app. App.py shouldn't be running the app because that is not immediately obvious that that's what it would do. So a run.py file tells us this thing runs the program. Run this if you want to run the program. App.py doesn't tell us anything about that. Finally, go into your config.py file, and we're going to create two config variables. Debug, which is going to be true, and admins, which is going to be a frozen set. And a frozen set is essentially just a set that cannot change. And if you don't know what a set is a list that has no duplicate values, pretty much. There are a few mathematical concepts going into sets as well, but we're not going to really look into them. Essentially, a set is unordered and has no duplicate values. That's what it is. And in here we can say your name at yourdomain.com. So we're going to expect our users, the administrators of this application, probably ourselves, to put their email address there. And this is so that we can notify them if something goes wrong. Debug is true, which means we can go back into our app.py, back into our run.py, and instead of debug equals true, we can say app.config debug. And now we have to load this config file into our app.config. So go back into your app, and under here, say app.config from object, and then config. Okay. So that is all the setup that we need. And now let's move on to the next video, where we're going to begin the development of the different models, and then move on to the templates and get our application ready. So I'll see you in the next video. Hi and welcome back. So in this video we're going to be creating the different models, and it's going to be a fairly short video. You may find it useful to look back into the mapping of our program file that we created a couple of videos ago. The first thing I'm going to do, however, is right-click on the app and close all, and just so I can close all those tabs there. And then I'm going to go one by one through my models and create the classes and create their constructors, which is going to define, therefore, the properties that each one of these has. So we decided the alert was going to have a user email associated with it. However, email is also part of user, so it's better if we use user instead. Then it's going to have a price limit, and it's going to have an item that is associated with. So self user equals user, self price limit equals price limit, self item equals item. Okay, now another good practice when creating these objects is to define what they look like if they were printed out to the user using the print method. So essentially, what is their string representation? And that is the rep method. And this simply has to return a string. So what I'm going to do is return an alert for user on item with price, and then format self.user.name or email self.item.name and self.price limit. I'm expecting my user and my item models to have these two properties. Okay, that's the alert model for now. We're obviously going to have more methods in it, but we'll do that in a later video. Go into the item.py, and this is also going to be an object. And then we'll look at what properties we decided it would have. And an item we thought would have a name, and indeed the alert was using the item's name, so the item has to have a name now. Or we can change both, of course. It's going to have a price, which we're going to load from the website. and it's going to have a URL associated with it. There's of course the potential for more properties to pop up as we develop. Okay, and then the wrapper method as well. And I'm going to skip the price here because the price is going to be loaded from the website, which means that when we're representing the item, it may not have a price immediately. And then .format, and this is going to be self.name, self.url. So this self.price equals price does tell us that the price has been loaded somewhere else, not in the item. So this is an interesting thing. We could create all of the item objects already with a price, which means we have to look at the price and then create the item object. Or we could create the item object without a price and then look at the price when we create it, or indeed afterwards. Those are some minor details that we're not going to worry with for now, and we'll think about later. I'll explain exactly what this means and why doing it different ways might be better or worse. Anyway, let's move on to the store, just so we can think about all the different properties of our objects. And a store, we agreed, was going to have simply a name and a way to check an item's prices. So maybe it's also going to have some sort of URL. The store URLs all begin with the same beginning, essentially. That sounds a bit redundant, but for example, if we were checking an item's price on Amazon, the URL is always going to be www.amazon.something, and all of the items in Amazon are checked in the same way. So I'm going to call this URL prefix. And what that's going to allow us to do is, when we get an item, we can check which store it lives in by checking this URL prefix, and then find the item's price through the store like that. And I'm going to leave the URL prefix out of this representation because I think it's not really necessary at that stage. But you can put it in if you want, of course. And finally, the user model is actually going to be very similar to the one we created in the last section. They're going to have an email, a password, and possibly a name. We may want to not use the name. Let's skip the name just for simplifying. And then self.email equals email, self.password equals password. And then the representation is going to return user with that email. Okay, so we may obviously want to add more properties later on to any of our models, and that is the entire point of developing things incrementally so that we can learn and we can understand our product better as we develop it, and that will allow us to have more flexibility and more agility in our development. Okay, so this was just creating the models, and now in the next video we're going to think about the different views. We're not really going to implement them all, but we're going to think about how the models interact with one another through the API. So I'll see you there. Okay, welcome back. In this video we're going to think about the first few views off the top of our heads and regarding all of our models. So if we go into the users.views file, here we're going to have the different views. And now remember, the view is simply the endpoint of the API that is related to the users. And as we agreed initially, we're going to be using blueprints to this effect. So let's create our first blueprint. we're going to need to go up and import blueprint. And then we can come down here and create the user blueprint. It's going to be a new blueprint. We're going to give it a name, users, and then we need to give it the import name, which is pretty much always going to be underscore underscore name underscore underscore. And this name is unique to this file when the app is running, so that's why we use that here. And then we can do things like give it a template folder or things like that, but we're not going to do that at this stage. We're going to do that later on if we need to, or in this case we won't need to because template folder is simply going to be templates. Okay, so then we can do at user blueprint dot root, and then, for example, login. We can have another one for register. We could have another for the different alerts that our users got. And I think in an application such as this one, we're not really going to be interested in looking at anybody else's alerts. That's just not particularly useful. So we don't need a root to look at somebody else's alerts. We don't need a root that says alerts / user ID or anything. Simply going to alerts will show us our own alerts, and that's it. Okay, and possibly one for logout. And let's leave it at that for now. When we need more, if we do, we will look into creating them. Okay, so that's the user views. And now we can go over into the store views. So we do the same thing once again, from Flask import blueprint. And then we create the store blueprint equals a new blueprint, stores, and then name. And here we can define the different endpoints. So store blueprint.root. And what sort of endpoints might we need for the stores? So for example, we might want to be able to check out a store name. So we would say stores, or rather store string name. And that would give us maybe some information related to the store. So this is only a sample view. We may use it. We may display some information regarding how to create alerts for that store or anything really. Or maybe we won't have any routes for the stores. Okay, and I really can't think off the top of my head why we would want any store routes. So let's leave it at that, and if we need more, we'll come back to it. Let's go back into our items and create our blueprints. And now we can find out what routes we're going to be defining for our items. So, for example, we could have one for checking out the name, or in fact it would be item/name. And this would give us some information related to the item that we're checking. For example, a pricing history for the item. And would we need any other routes for an item? Potentially not. Or for example, item blueprint.root, and then say something like load item, and this would load an item. And we may want to, in fact, do this, type three quotation marks, and here we can write some explanation as to what the method does. So this method is going to load an item's data using their store and return a JSON representation of it. So for example, we may want to be able to do that later on. Okay, finally let's go into our alert views and once again do the same thing from Flask import blueprint and then create your alert blueprint equals blueprint alerts name, and then we can define the endpoints for the alert blueprint. So for alerts, we're going to want to be able to create an alert. We may want to say new. And the method is going to be post because we're going to be sending data, probably in JSON format, and we'll learn how to do that. We are probably want to be able to deactivate an alert. And we'll pass it the alert ID to deactivate. And what else? We may want to check out an alert that we've already created. So it would simply be string alert ID with alert here. And I can't really think of any others off the top of my head. We want to create, deactivate, get the alert page so we can see it, and then the alert is going to show us some information about the alert that we've created. We may be able to visit the item page, but we've created a view for that. We could visit the store page, possibly not. I'm not sure if there's really a use case for that. And we can log in and register. Okay, that is probably around what we need, and we would also need a way to get the alerts for a specific user. So we're not done yet. Root alerts, that's going to be the URL prefix. So for user, for example, okay, and if we go into our user views once again, we should have a root here for check alerts. That would check the alerts for a specific user. Okay, so we have created a number of endpoints. Some of them may be useful, others may not be useful, such as the store one. But what's important here is that you remember we are thinking about how the program is structured, how things are going to interact with one another. If you think I've done something stupid, then I might have, and if you have a better idea, then by all means go for that instead. As we develop and we learn about the interactions between our models and the way that users are using our application, because that may change. The mental model that we've got may be different from a reasonable mental model. So as that develops and as we learn about it, these things are bound to change. But let's not get caught up in that, and let's keep thinking about how these things are going to go, and we can keep developing and make sure that the end product, which is the thing that matters, actually makes sense. So I'll see you in the next video. Hi and welcome back to the course. So in this video we're going to be logging in our users. This is going to be a video to implement the entire sort of database, view, model process for logging in the users. So the first thing to do is to make sure that we can access our database. And we did this in the last section, and it was not a big problem. We simply have to create a database class and then give it a couple of methods that will allow us to insert data and find some data in the database. So instead of boring you just typing it out, what I'm going to do is I'm going to paste it in. And this is exactly the same code that we had in the last section. So exactly the same, nothing has changed at all. As you can see, we've got the universal resource identifier, which is where the MongoDB database is. And this starts with MongoDB : // This looks very much like HTTP, except instead of HTTP, it's MongoDB. It's just a different protocol. The address of the computer in which the database is, and 127.0.0.1 always means in all instances the local machine. So in your case, your computer, in my case, my computer. 27017 is a default MongoDB port, and if you're running it on a different port, then you're going to have to change that number. But if you're just clicking on the icon or running it through the terminal, then it'll be that port. The database is initially none because we haven't initialized it, and then when we initialize it, then we say that this database variable now contains the database that we're using in the application. So we're still using full stack. We may change this later on when we're using a more when we're building a more complex application, but for now we're building something quite simple, so we may as well stick with it just for now. Okay, so next let's start with the user model. So here we've got the user model that we created previously, that as you can see is very simple. Simply initializes the user with an email and a password, and doesn't do much else. Something that we have to do that we did in the previous section, and we are going to do here again, is the _ID. So _ID is going to be none when we create a new user manually, but when we create it from the database, then it's going to have an ID in the database, and it's going to give it to the user model. So then we'll do what we know. Self._ID is UUID4.hex. This gives us the unique universal identifier for this user, and we have to import that. UUID4 is simply a way of generating these identifiers. There's a few other ways, and you can explore them if you want. And .hex simply gives us the hexadecimal string representation of this identifier. If not, it would be an object of type UUID, which we cannot put into the database because it's not a string. MongoDB doesn't support that. Although I'm lying, it kind of does, but it doesn't work quite as well as using a string, so stick with a string. So we want to do that if we're not giving the user an ID. And if we are giving the user an ID, then we want to use that ID instead of that. So if we give an ID, we're going to use that ID, and if we don't give an ID, then we're going to generate a unique one. So that's what we want. And then let's move on to creating the isLoginValid method. This method is going to essentially check whether the email and password combination that we're verifying is valid or not. So this is going to be a static method. The reason it's going to be a static method is because we're not going to be talking about a specific user object. We're simply going to be talking about email and password combo as a general sort of thing and not as a specific user. So when we're checking this at the stage in our sort of process pipeline that we're going to be checking this, we don't yet have a user. We're simply checking if the email and password that they've put in is valid or not. If it is valid, then we'll be creating the user object with those. So I'm going to call it isLoginValid. You can call it whatever you want, but try to make sure that it makes sense. And it's going to take in an email and a password. And now I'm going to write a short Python documentation snippet here, just to explain what this method does. So this method verifies that an email password combo as sent by the site forms is valid or not. Checks that the email exists and that the password associated to that email is correct. So the email is just a string. And the password is actually going to be a hashed password. And let me explain what I mean with this. True if valid, false otherwise. So what is a SHA-512 hashed password? And why are we getting one of those? So when the user presses login on the website form, they are going to be sending us some data. Well, the form is going to be sending us some data. The data is going to be sending us, it's the email of the user and their password. So think about what would happen if somebody on the internet intercepted that data. They would be able to see the user's email, which, yeah, it's not ideal, but it's not that big of a problem either. You can't do much with an email only. Maybe you can send some spam or something. But getting the user email is not the worst thing in the world. And they could see the password. So the password is a bit of a problem because, as we know, everybody uses the same password for everything, or maybe 3 or 4 different passwords. Most people don't use something like 1Password or LastPass or KeePass that allows you to generate unique passwords for everything. So they would be using the same password for everything, which means that not only would their password for our service be compromised, but potentially for other services as well. So the reason we need security in our applications is not only for our application's sake, but for the user's sake as well. So the reason we're getting a SHA-512 hashed password, which is essentially just a method of preventing anybody from understanding what the password really is, essentially encryption. The reason we're sending that is so that if somebody intercepts the password, they won't be able to read it. And there's going to be a short lecture coming up on the different types of encryption and what they mean and what they're used for shortly. So don't worry much about that. Simply remember, we're going to be getting a SHA-512 hashed password from the login and register forms. We're not going to be getting a plain text password in this section. We did get a plain text password in the last section, but that's obviously not very safe. Okay, so the first thing we're going to do is check that the user exists. And for that, we're going to need to look into our database. So we're going to be looking into the users collection, see if there is a user with the email that the user has sent us through the form. We're going to need to import this database. So if the user data is none, we want to tell the user that their email doesn't exist. Okay, and we're going to do that in a moment. Pass simply doesn't do anything, so we're not really doing anything just now. So if the user data is none, we're going to tell them that it doesn't exist, and if the password is wrong, and I'm going to explain exactly what I'm doing here. Tell the user that their password is wrong. So what am I doing? If this method that we're going to create momentarily, called checked hashed password, returns false, it means that the password that they gave us is not the right password, and then we're going to tell them that their password is wrong. And if the user data existed and the password was right, then we can simply return true because everything is okay. Okay, so let's create this method to check the hashed password. So I'm going to go into my utils, and I'm going to create here a class utils. And then we're going to create the method that is going to check for whether the hashed password is right or not. So it's going to be a static method, and it's going to be called check hashed password. And what it takes is a password, a password and a hashed password. And once again, I'm going to write another short amount of code, a short amount of comment here to describe what this method is. So password, I'm going to go back to the user and check that password is the password the user is sending us, and user data password is the one that's stored in the database. So that's important to keep in mind. Checks that the password the user sent matches that of the database. the database password is encrypted more than the user's password at this stage. So what this means is the password the user sent us, we know is SHA-512, SHA-512 hashed password. And the password that is in the database is actually going to be encrypted using an encryption method called PBKDF2, which is a much more secure method, but it's also a bit slower to encrypt using it. So PBKDF2, I don't know why they put such complicated names, SHA-512 encrypted password. Notice there is a difference between hashing and encrypting a password, but we're not really going to get into that in this video. So this returns true if passwords match and false otherwise. And the only thing this method does is it returns a PBKDF2 SHA-512 verification of the password and the hashed password. And we of course are going to need to import this, and where we're going to import that is from passlib.hash import PBKDF2 SHA-512, and we're going to need to install passlib. So we go to our requirements.txt and say passlib equal 1.6.5, which is the latest. Then go back to our utils, install that, and as you know, PyCharm tends to be not too great realizing when these have to be refreshed. But trust me, that's all you need. And there is a lot of potential. It certainly happens to me a lot when I use passlib, that it will not know that this exists, and it will tell you that it doesn't exist. But do not worry about that. It does exist. So even if it keeps being red underlined all the time, that's fine. So now that we're here, let's also create another static method to hash a password, which just takes the password in SHA-12, hashes a password using PBKDF2 SHA-512, the SHA-512 password from the login or register form, and returns a PBK in SHA-512 to PBKDF2 SHA-512 encrypted password. So remember, the algorithm we're using here is PBKDF2 underscore SHA-512. The password is already coming as a SHA-512. So this double encryption is quite a contentious thing. A lot of people disagree with double encrypting. I don't see it as a problem, and I think it slightly improves the security, but not a lot, but it's still worth doing. So if you don't understand why I say it's not a lot that it improves security, then I'll go over that soon in the lecture. Okay, so what this does is simply return PBKDF2 dot encrypt the password, and that's it. So when we're registering our users, we're going to be using that. Okay, let's go back to our user, and notice how here we're finding the user data. So this password in SHA-512, and then when we check the hashed password in SHA-512 PBKDF2, so the user in the database, because we would have encrypted the password as PBKDF2 when we register them, the password here is already in SHA-512 to PBKDF2 underscore SHA-512. So we need to check that, but we also need to remember that this has been hashed twice. So unencrypting the one in the database would give us a SHA value, a hashed value, not a plain text password. So remember that. Okay. So if the user data is none, we need to tell the user their email doesn't exist, and we're going to do that with an exception, with an error. So go into users and create a new Python file, which I'm going to call errors. And if you don't get that other message about adding the file to Git, do not worry. I'm just doing that so I can show you these examples online, but you don't have to worry about adding things to Git or anything just now. We will cover that later on in the course. Okay, and then I'm going to create a class called user not exists exception, and I'm actually, instead of exception, I'm going to call it error. You can call it whatever you want, and this is going to take a message, and it's going to say self.message is message. Okay, so what am I doing? I'm going to create a class called user_not_exists_error, and this, I'm going to tell it that this is a type of exception. So it's going to contain everything that the exception contains and potentially something more. And the thing that it contains more is this init method, so this constructor. So when we create a new exception of this type, we're going to give it a message. And the message we're going to give it is going to be stored inside the self.message, which means that another part of our program can access that message. For example, we can create this exception in our login, and if the user doesn't exist, we would raise an exception. That's what it's called, raising an exception. And then the front end could catch it and show the user a message saying your user doesn't exist, for example. Okay, and I'm going to copy that one and call it incorrect password error, and it's going to be exactly the same. And you should already have alarm bells ringing in your head. Two things are exactly the same. This is not a great thing, and we're going to go into that in a moment. And then in our user model, if user data is none, we're going to say raise user not exists error, saying your user does not exist. And we need to import that, and we'll do that in a moment. And if the password is wrong, we're going to say incorrect password error and say your password was wrong. Okay, so we need to import them. But I'm going to import them in a slightly peculiar way. So from src.models.users.errors, my bad, not from, import src.models.users.error at as user errors. So what this does is it imports this file that we just created with our errors, and it calls it user errors inside the current file. And now we can say user errors dot user not exist error, and I quite like that. I think that's very readable. So we can do that and call it user errors dot user not exist error, and now we know that this error is only specific to users. We'll also need to import utils. So we have that method there. Alright, so now we've got that, we are able to check that the user has logged in. We're still missing, however, the view, so we're going to implement that in the very next video. So I'll see you there. Hi and welcome back. So in this video we're going to be checking that the login all works. So we're going to connect this model method with the rest of our application using the view that just now is empty. Remember, this model is part of a web application, so testing it is fairly difficult without using the web. So we need to create the view so we can check that everything works by using our browser, or by what we're actually going to be doing, using a program called Postman that is made for verifying these sort of things. So let's go into our views and look at the login view here. The first thing we have to realize is login has two different instances, or two different options for it. In one of these options, the user arrives at the login page with their browser, and then what we want to do then is give them the login form so they can fill it in. In another of these options, the user has already filled the form in and they've pressed the submit button. So we want to do something with the data. So as we know, this means there are going to be two types of methods, which we can put here with a comma after the endpoint. There's going to be a get method, and a get method simply requests something from the server. So what we're going to do if the user sends us a request, a get request, is give them the login form, give them the data that they want. And the other option is a post request. The website is sending us some data. So what we're going to do with that, because we know on this login endpoint the post is only going to contain an email and a password, is we want to do something else, like, for example, save it to the database or check that the login is valid. Okay, so if the request method is post, then we need to import request. Then check login is valid, and if not, then we're going to do something else. So check that the login is valid. How do we do that? we simply get the email, request.form email, and the password, request.form. But now instead of password, I'm going to say hashed. And because this is going to be the hashed password as opposed to the plain text password that we were getting in the last section. So we already know what this means. We're simply getting the form details from the request. Okay, and then if user.isLogin valid for this email and password, we need to import user. Then we can simply say session email equals email, and what this does, it puts that email inside a session, and we need to import that. And as you know, what the session is simply a temporary storage of data. So the session for this user is linked to the user via a unique ID that is stored in their browser. So when the browser arrives at a web page, we give them a unique identifier, and they send us that identifier with every request. So we know that browser is related to this email. And Flask does all of that work behind the scenes for us. The only thing we have to do is session email is email. That's it. And then Flask will know whenever a request comes in whether they've got an email or not. And then what we do is return redirect, because we're going to redirect the user from the login page into another page. And the page we're going to redirect them to, URL 4, is the user underscore alerts page. So let's import these things first, and then I'll let you know what they do. So URL 4 simply gets the URL in our service for a specific method, and the method is the current file user alerts. So that is essentially the user profile, isn't it? Redirect simply returns a 301, so that's a HTTP status code that tells the browser, instead of the location you're in right now, change over to this other location. So it will change the address, essentially. So what if the request method is not post? Then we'll say return render template. We need to import that, and the template we're rendering is user/login.html, and I realize this template doesn't exist just yet, but it will. What that template is going to be is just the login form. So there is a small flaw in this method, and I'm going to explain why there's a flaw and how we can solve it. The request method, imagine, is post. So the email is the form's email, the password is the hashed password that we get through the form, all good. We check if the login is valid with the email and the hashed password. And if it is valid, then we store the email in a session, and then we redirect them to the profile. Brilliant. Let's imagine another scenario. The method is get. So the request method is post. No, that's not true. So then we return the render template. Brilliant. Let's imagine a third scenario. The request method is post. They send us an email and a password, but the user login is not valid. So we don't return a redirect, but the method is still post. So it kind of goes here, and then it just leaves, because it doesn't go into this else, because this else is related to this if here. So essentially what is happening here is we're doing return none. And we don't want to do that. We don't want to return none in an endpoint, because when that happens, if we return none, is it simply doesn't do anything. Or, worst case scenario, it gives us a really ugly error, saying endpoint didn't return data, and then our users would be very confused. So we don't want to do that. What we want to do is, in fact, remove that else and put that here. Let me explain exactly what happens. Method is post, email and password are valid, so this is valid, we redirect to the user alerts. Brilliant. The method is not post, it's get, so it doesn't execute any of this, and instead it just jumps into outside of the ILF, so it does exactly what we wanted, returns the render template. And if the user's login is invalid, then it doesn't do this, it simply jumps out of the outer ILF and continues here, rendering the template again. So if the user login is invalid, we'll render the login template, and if the method is not post, means the user arrived at our page, we render the template as well. Some obvious areas for improvement that I'll leave to you is send the user an error if their login was invalid. So this is going to require if and else, for example. Okay? And we will do this towards the end. So you can attempt it now. We will implement this towards the end because there's some more flaws left here, but we're not going to get into that just now. Alright. So now we're able to redirect the user to their profile or to the login page, depending on what they're doing. If they're sending us data, we'll verify the data and send them to their profile, and if not, we will send them over to the login.html page. Alright, so in the next video, we're going to be checking that this all works, but first, we need to make sure that the blueprint is here. So from source.models.users.views import user blueprint, and then say app.register blueprint user blueprint with a URL prefix of /users. Okay, so what this does is simply register the blueprint with the prefix users. So now /users/login is going to be the login endpoint that we just created. And also what we have to do is make sure that the database is initialized. So I'm going to remove this hello world and then say at app before first request, say initdb database.initialize. And we need to import that. Alright, so now we're ready to go and test this and see if everything works. So I'll see you in the next video.
Hi and welcome back. In this video, we are going to be creating a user that then we're going to use to test our login endpoint to see if it works. So the first thing to do is to make sure that MongoDB is running, and the way we do that is just by typing MongoD in our terminal. And now that's running, so we can now add our user. So what to do is go into PyCharm, and then in the very top menu there's a Tools section that we can press, and then open up Python console. If you're using PyCharm Community Edition, which is the free edition, you may have a few fewer options here, but nevertheless you should still have Python console. So open that up, and then what that brings up is a Python interpreter, an IDLE like we saw in the first section, an interactive interpreter that we can use in the context of our project. So what this means is that we can import our project files and we can execute them. In this case, what we want to import is the file that is allowing us to encrypt our password. Remember that our login endpoint and the entire login functionality behind that endpoint is going to take the SHA-512 password that we get in from the form, and it's going to encrypt it when it puts it in the database. So when it checks the login endpoint, it's also going to encrypt it to verify that it is the correct password. So what we have to do here is say from src.common.utils import, and then we can say the encrypt function, which I'm going to open here, common utils, the utils class, and the function that we want to use is this hash password function. So coming back to here, we want to say utils.hash password and then type in a password. Now, if we type 123 as our password, then we get back the encrypted version of 123. Notice that every time we run the encryption method, the outcome may be different. So notice here the outcome is different at the end there, and that's totally fine. The information that is stored alongside with this with the encrypted password allows our utils method called checkHashedPassword to verify that 123 was the password you put in. So if we pass this entire thing to checkHashedPassword, utils.checkHashedPassword 123 and that, it says true. And similarly, if we get that and do utils.checked hashed password 123 and that, it also says true. Notice that if we copy that entire thing, paste it in, and we change something in the middle, such as this 0 there, I'm going to change it for a 1, now it says false. Okay, so exactly what you would expect. Just notice that every time you run it, it's different, and that's a good thing because it means it's a bit safer. It's a bit more difficult to decrypt and to break it. Okay, so this was a small aside. Now we know that when we register users, we are going to be writing to the database something that looks like this, more or less. However, the form that is going to be in the front end is not going to give us 123. What it's going to give us is a SHA-512 encoded version of this string. So what I'm going to do is I'm going to go into Google and just type SHA-512 of 123, and then it'll give you back a long string, and that's your SHA-512 encoded string. So I'm just going to do that right now, and I'll be right back with it. So once you've Googled for SHA-512 123, you should get back a very long string, which looks more or less like that. So this long string is just 123, but encoded using the SHA-512 algorithm. So notice that the algorithm we are using for encrypting the password is PBKDF2 SHA-512. And something that is encrypted can be decrypted fairly simply. That is why the checked hashed password method exists. However, the string that is the SHA-512 encryption of our number 123 cannot be decrypted. Okay? However, every time you encode something in SHA-512, the same output comes out. So that's the difference between this PBKDF2 encryption and the SHA-512 by itself. SHA-512 will always render the same output for a given input, and this PBKDF2 will render different outputs, but it can be decrypted. So how do you check that the password as given by the form is 123? Well, you simply encode using SHA-512 this thing and verify that, I'm going to write some pseudocode here, verify that the SHA-512 encryption of 123 must be equal to the string that you know to be the SHA-512 of 123. So this is how you would verify, but you cannot convert this string back to 123. That cannot be done. The only thing you can do is encrypt 123 again and verify that they are both the same, and that's how you know that 123 was this string here. Okay, so now that we've got our SHA-512 version of 123, we can register a user, put them in the database using the password. So we're going to put into the database a user, and the user is going to have an email and a password. The password is going to be utils.hashPassword, and the password we're going to be hashing is the SHA-512 version of our password. Remember, the form in the front end is going to be giving us a string like this one, a SHA-512 encryption, and then we are going to encrypt it with Python into PBKDF2, and that is what we're going to be writing to the database. So this is the password for our user. Now what to do is go into the terminal, which I'm going to do just now, and open up a new tab and open up Mongo, then use the full stack database, and then say db.users. I'm going to find to check exactly the structure. Notice how right now we've got some passwords in there, and all the passwords that we've got are in this format with PBKDF2 at the beginning, and that's absolutely fantastic, except this one, which is evidently a test. So what we're going to do is we're going to say db.users.insert, and then what we're going to insert is something that has an ID like this one. So underscore ID is just going to be something like that. So I'm just going to change a letter. That is fine. And then remember, this is a UUID, and if you don't include it, it'll put in an object ID as above, and that won't work. So make sure to use just a string UUID, and then the email is going to be just anything you want. I'm gonna use test2@test.com, and the password is going to be the encrypted password that we saw just a moment ago. Notice how there is a quotation mark at the beginning. We're going to have to go back, unfortunately, and remove that. So there's going to be a fair bit of scrolling here. So that's now removed, and now we have to go back and make sure to close the dictionary and the bracket and everything. So once you've done that, now you've got a user that you can test your database with. So there we go. Now that's inserted. And now in the next video, we're going to be going over how to use Postman to test our login endpoint. Remember, in Postman, you'll have to use this email and the SHA-512 password, because Postman will not work with just 123. But we'll cover all of that in the next video. Okay, so now that you've got this in your database, we are ready to move on and actually test the endpoint. So I'll see you there.
Hi and welcome back. So in this video we're going to verify that we are able to log in. There are a couple of things missing from our application before we can do that, however. The first one is to allow sessions to be secured. And what that means is when a browser comes into an application and requests a page, Flask is going to put a cookie in them with a session ID. And this session ID is going to be used to link that browser to a specific session in our server, and that session in our server is going to contain things like the session email, which we use to verify whether a user is logged in or not. So in order to secure those cookies that we're giving the browser, we need a secret key. So app.secretKey is 123, and this secret key, as the name implies, should be secret, and it should also be secure. So normally what you would use is 32 characters of random letters and numbers. For the purpose of this, we don't really care, but if you were making an application that is going to be used online by people, you want a secure key here. And we will go over how to get a secure key later on. Something else we need is to go into the views and ensure that the alerts page is returning something. So return, this is the alerts page. And we need this because when we log in and we redirect to the alerts page, if we simply have pass here, it returns none, and then we would get an error. A Flask would crash essentially, so we don't want to do that. We want to return something, anything, doesn't matter what. Even if you want to return an empty string, that's fine. Okay, so we are now ready. Remember, you need to ensure that your MongoDB instance is running locally, or wherever that you're running it, and then simply press run in our app, and then we can open up Postman. So this is Postman, and we haven't seen this before, but let me just explain real quick what the different parts are. We've got a collections, which contains the requests that we've saved, so we can create new requests, test them, and then save them. And I've got here a couple of them, a couple of folders that I've got for other things, so nothing to worry about here. And we can create new folders, and we're going to do that just now, called price alerts, and say this is a collection for price alerts system. Awesome. Okay, so we can make a collection there for ourselves, and then we've got the main bit here. So we've got a set of tabs that we're not really going to use. We've got something called Flask Local. We're not going to use that just yet, but we will look into it later on. And Postman has users, and you can log in and register and things like that, but I wouldn't worry about that just now. This bit here contains the HTTP method that we're going to use, and we've only looked at get and post, but as you can see, there's a few more. There's a lot more. So we're going to use get and post. In this, here we're testing whether we can log in, so we're going to use post. Here you enter the request URL, so as you know, HTTP 127.0.0.1 is the server or the location where the program is running, 4990 is the port, and then the endpoint is /users/login. Okay. And then we've got a few more things. Authorization is whether we're going to use some sort of auth. And in our program, we're actually not going to be using auth. We've programmed the authorization ourselves. Headers are things that the browser can send to the server to tell it what sort of data to expect or things like that. So we're not really going to worry about that just in this video, but we will come to those later on. Finally, the body is what we are sending the server. So in a post request, we're sending something, and what we're sending is a form data type. And this form data type contains an email, which is my email, and it also contains a hashed password, which is going to be paste the hash of the password. So my password for this is 123. But remember that our form in our website is going to hash this password, is going to use a SHA-512 hash before sending it to the server. So really the server, the only thing they see is the SHA-512 hash. They never see 123. So what we want to make sure is that we go on Google or DuckDuckGo, find a SHA-512 hashing page, and just put 123 and get the hash in. And then you'll get a long string of text like that. So that is what the server sees. This is my password for the server. And now I can send that to them. So let's send it. And there we go. We get this is the alerts page, because that is what happens when we log in successfully. So as you can see, if I put in 123 here, we get an incorrect password error. Your password was wrong, because the server didn't expect 123. It expected the hashed version of the password. Postman gives us a bunch more data, like the body of the page, cookies, and we can install an extension to be able to see the cookies, headers that the server sent back. In this case, for example, text/HTML is the sort of content that we returned from the server. And also something like status, 200 OK, that's the most common status that you'll find, and how long it took for the server to respond, things like that. So Postman is a great tool for rapid testing of these APIs that we're making. So that was a quick intro, and now what we can do is save it into our price alerts and give it a name such as users/login. You can give it a description if you want, and then simply add it. And there we've gone, our request saved. Whenever we make a change to our login system, if we do, we can come back and send this again and see if it works or not. Okay, quick intro to Postman. Hope you enjoyed that, and I'll see you in the next video. Hi and welcome back. So there are a couple of things that can go wrong in our program right now, which is what this comment describes. This comment says send the user an error if the login was invalid. So that entails email not existing or password being wrong. So what we have to wonder is what happens right now if the password is wrong. So let's go into Postman, and remember that if we just send that, then we get this is the alerts page, because that means the login was successful. But what we want to do is remove one of the characters from here and see what happens. Oh dear. Let's go into our application and look at the massive red text that we just got. So what does this mean? So essentially at the very end we got incorrect password exception. Okay, so we know that the password was wrong, that's fine, but what do users see? Let's go into preview. And this is what our users are going to see when they put their password in wrong. Alright, so we don't want our users to be seeing this. Nobody wants to see this. And if they do see this, they've got a lot of information about our code as well that we don't want them to know. They know we're using Flask, they know how our errors are structured, that we've got a method here, and they know that the traceback, this is not very safe for us, and it's not very friendly for them. So what do we want to do? We want to make sure that we can show them a specific error. We want to make sure that we can tell them, sorry, your password was wrong, but here, try and log in again, as opposed to simply presenting them with a massive text with the errors in it. In order to do that, we are going to need to catch the exception that we are raising in the isLoginValid method. So I'm going to go to my user, and in the isLoginValid method, remember we are raising an exception. So this exception, what it's going to do is it's going to get raised, and then wherever it goes, we can catch it and do something with it. So it gets raised, and then it comes back to the view in here. So now there's an exception here, and we can catch it, and we can prevent it from being shown to the user, and instead we can show the user a message that says, your password was wrong, try and log in again. So how do we do that? We're going to surround this code with a try, and then that, and then at the end, except block. And in this except block, we can return, for example, your password was wrong. Sorry. Okay, so I'm going to restart the program now, and then go back into Postman, and then send again. And now we're getting a nicer message. All right, so we're in the right direction. And notice how this is what I'm doing, changing a bit of code, going back into Postman and testing it, and then changing a wee bit more, and then changing and testing it again. This is what you should be doing as well. So we've got now a slightly better error message. However, if my user doesn't exist, I still get the password is wrong. So we don't want that. And that is because in the user, we're raising two different exceptions. We're raising user not exists error, and we're raising incorrect password error. They have different messages. But in the view, we're just catching everything, all exceptions, no matter what they are. We're going to catch them, and we're going to return this one message. So we're not going to behave differently for each exception. So how do we do that? Let's say except user error, which we're going to import from the errors.py here. Right, user not exists error as E. We need to import that, and we're going to do the same user errors dot user not exist error, and then import src models users errors as user errors, except user error user not exist errors E, and then say return E dot message. And then we're going to copy that except bit and paste it again, and now instead of user not exist error, we're going to use incorrect password error and then print out e.message. Okay, let's restart that and request that again. And now it says your user does not exist, and if I put the e back in, now it says your password is wrong. Excellent. So now we're able to show the user a message. However, return e.message and return e.message is duplicated. We don't like duplicated things. So what we're going to do is go into our errors.py, and we're going to create another class. And this class is going to be called user error or something along those lines. And what this class is going to do is it's going to contain this init method, which is going to say user error has a message, and when we give it a message, we're going to store it in self.message. We know that, but these exceptions have the same code. So what we can do is, instead of having all of them subclass exception and come from exception, we can now say user error here. And in here, we no longer have to contain this init method because it is contained in the user error. And this exception is going to inherit and contain everything that user error contains. So we don't need it because it's duplicated. So we can just say pass. And we're going to pass. But these exceptions still have this method in them, and they still have self.message. So we can come back to the view, and instead of doing this twice, we can simply say user error as E, return e.message. And now we would catch both. So I'm going to restart the app again, go back into Postman, send that, my password is wrong, remove the E, and I should get my user does not exist. But the code is prettier, and we've removed the duplication. So now we can return a message, but what we really want to do, and we will do this later on, is to return this template with some sort of pop-up or something that tells the user, we've redirected you to the login page because your user was wrong or your password was incorrect. So we want to do that, and we will do that later on. For now, it's worth still implementing some basic error checking there to ensure that the users aren't left confused and they aren't able to see our code. Hi and welcome back. So in this video we're going to be starting work on registering our users. Registration is actually going to be extremely similar to logging. The only thing we're going to change is instead of checking whether the user exists and then logging them in, is we're going to check whether the user exists, and if it doesn't, we're going to add it in and then log them in. So we're going to add a new step there, but the view is actually going to be fairly similar. So we're going to copy that, add the methods in here, and then paste that in here instead of pass. This is not going to change. If the request method is post, then we're going to get the email and password, but this is going to change. Instead of isLoginValid, we're going to create a new method called registerUser, and that's it. So if the user is registered, then, well, if the register works, we're going to log them in by adding the session, the email to the session, and then we're going to redirect them to the user alerts. And if they didn't manage to log in, then that's going to raise some sort of user error, and we are going to return them to the register page. Finally, if the request method is get or something else happens, we're going to return to the render template. So remember, right now, if the user already exists or the registration fails because of an error, we are simply going to show the message of the error. We're not going to redirect them to register page. We will do that later on in the course. Okay, so that's it. The only thing we have to make now is this register user method. So let's go into our user model and then create a static method called register user that takes in an email and a password, and we can work on getting this set up. So the first thing we have to do is check that, well, the first thing we will do is write some short comment here to tell us what this method does, just so we can remember later on down the line what it is, and also if you want to go and check this online, that you've got some comments here explaining what things are. So you don't need to write the comments if you don't want, but I'll do that for you guys. So this method registers a user using email and password. Email and password. The password already comes encrypted, hashed as SHA-512. So the email is the user's email, which might be invalid. Password is a SHA-512 hashed password. So this returns true if registered successfully or false otherwise. Exceptions can also be raised. Alright, so the first thing we have to do is get the user data. So what I'm going to do is just copy that. We're going to find a user in the database with this email. So what do we want it to happen? If the user already exists, means we cannot register this guy because he's already in the database. So if user data is not none, tell user they are already registered. So notice how this is different from above. In the login, we were checking that it is none. Here, we're checking that it is not none. Because if it is not none, it means it exists. And we want to tell them they're already registered. Another potential problem is that the email that they give us is not a valid email. So we're going to check that. So if not utils email is valid, and we don't have this method yet, but we're going to make it in the next video, then we're going to tell the user that their email is not constructed properly. And finally, what we'll do is we'll create a new user with the email and the hashed password. Remember, we want to hash it using the encryption method that we implemented in our utils class. And then we'll simply do save to DB. All right. So finally, we'll return true, of course. Okay, so easy methods, save to DB. Save to DB is simply database.insert in users with self.json, and we know how this goes. Def.json simply does return, and I know that this is going quite low down. Return ID is self.id. Email is self.email. Password is self.password. Okay, so we can save to DB, that's not a problem. We've done this before, we know how that goes. The only thing we have to work on is on checking whether the email is valid or not. In order to do that, we're going to be using regular expressions. So let's move on to the next video to not make this too long, and let's start looking into that. I'll see you there. Hi and welcome back. So in this video we're going to be analyzing how we can check whether an email has the correct structure or not. So in order to do that, we're going to be using regular expressions. And regular expressions is actually quite a complex language. And I say language, and I hesitate when I say that because it's not a programming language by any means, but it is a language in the way that it has its own syntax and it's used for its own thing. And what it's used for is to describe the structure of strings. So essentially, the way the regular expression works is it has a regular expression pattern, which is called a matcher, and then it's got some text that you're searching through. So here I'm using a program for Mac, but there's plenty of websites for regular expression pattern matching that you can find, and I will link some below as well. So say we're, for example, verifying the structure of hello world. So this would be the simplest way to do regular expression. Simply type in the characters and then you can see that it matches, but the others do not match. So it only matches that exactly. As you can see, the one in yellow is that, but if I add a bracket there, sorry, an exclamation mark, then it matches that one as well. Okay, so that's the simplest way to do it. The next best way to do it is to say dot, and you can see that everything matches the dot, and the dot is simply any character at all. Dot star matches a full line of things because it matches all of the characters in one line. If we do dot plus, that also matches all of the characters. The plus, however, means we're only matching one or more characters and not 0 characters. Okay, so what other things can we do? We can say, for example, the open and square brackets means a group of characters. So, for example, we could say A to Z. And in regular expression, that means all of the letters between A and Z. Notice how hello does not get matched because it is not between A and Z, it is between A and uppercase Z, and now it is matched. So A to Z does not match the comma or the space or the exclamation mark, but it matches everything else. A to Z star matches all of the words, but not the spaces or the comma or the exclamation mark, as you would assume. If we say A to Z star and then a comma, we're only matching the hello with a comma at the end because it matches this exactly. So it finds out where there's a string of characters in a row with a star and then with a comma. So that would be hello comma. If we add a space, then it would match the space as well. So if we say A to Z star, comma, A to Z star, that would match hello world. And if we add the exclamation mark at the end, that would only match the first one, which is the one with the exclamation mark. We can also say \d, which stands for digit. So that would match things like 1, 2, 3, 4, 5. If I can type. So how would we match an email address, like mine's? I'm going to delete those other things because they are getting a bit confusing now. So let's begin. Let's start at the beginning of the email address. That's simply letters and potentially numbers as well. So \w plus, that's matching the words. Remember that emails can only have letters and numbers, but they can also have dashes. So I'm going to add that in there. And notice how this is doing any letter or number and any dash any number of times. So this is actually accepting things like multiple dashes, which normally is not valid, but that's fine. Then the @ now only matches the beginning of the email address. And then we've got \w plus for the remainder. And do remember that you can also have dashes there as well, so we'll keep those in. And then we would have something like full stop and then another set of words plus. And now that matches the entire email address. So why am I doing this? Why am I putting the \/ before the dot? That's because in regular expressions, the dot means any character, as you know. So we have to escape the dot so that it actually matches the full stop and not just any character. So what happens when I change .me for .co.uk? There we've got a small problem because the .uk is not matched. We're matching Jose at School of Code, the full stop, and then .co. But we're not matching any more elements here. So what we have to do is actually say, wait a minute, this, any number of letters and the full stop can actually be repeated any number of times until we get to, for example, blah.ac.co.uk or whatever, you know. There can be many of these full stops and many of these things depending on what sort of domain we're in. So what we want to say is the letters and the dot can happen many times. So what we'll say is put some brackets around that and then put a plus. So what that does is the letters and the letters can happen many times, and then there's a dot, and those letters and dot can also happen many times. At the end, there will be one without a dot, because email addresses cannot finish with a dot. And this is how we would match emails. Now, in order to be fully consistent with the regular expression standards, we should also put that at the beginning, and this means this is the start. That is so we won't match anything that's in the middle of something else. And in order to fully comply, again, we have to put the $sign at the end, which means this is the end. So basically, when we give our regular expression pattern matcher some text, we will only match the text that is at the very beginning of the string and that ends with the very end of the string. So if we have a $sign at the beginning, for example, we will not match that. Whereas if I remove this, we would match the email address, but not the $sign. So what we want to make sure is we're matching the string only if the entire contents of the string we're matching is the email address. Notice that if I do that, it also does not work. So this is the start of the string, this is the end of the string, and this is how we would match the email. So now what we're going to do is we're going to put this inside our method in Python to verify when we get a string that is an email address or not. I'll see you in the next video. Okay, so welcome back. Now that we've looked at what the regular expression is going to be like, we have to go into our utils and actually implement that. So let's open up the utils file and let's create a new static method which is going to be email is valid, and this takes in an email. In order to use regular expressions in Python, we need to import a package called re for regular expressions, and then we can actually check whether the email matches the regular expression pattern or not. That's actually really simple. What we're going to say is email address matcher is going to be re.compile, and here we're simply going to give it the pattern. So as we know, that to match the beginning of the string, that to match any non-white space characters, that to match dashes, plus to signify more than 0, so one or more, at, and then we'll say that plus, so words dash plus any number of them, and then full stops potentially, and then a plus as well. So that would mean any number of words or dashes, and then any number of full stops. So for example, something like hello.ac. And at the very end, we're going to say another one of these plus $. Alright, so start of the string, and then any number of words and dashes, at any number of words and dashes with full stops potentially at the end of them, and at the very end another word, and then at the end of the string. Alright, and then we'll say return true if email address matcher match email, else false. So if this matcher matches the email, then we'll return true, and if not, we'll return false. And that's everything we really need to check. If we go back to our user model, we'll see that now that says it's fine, and the only thing that's left is raising the appropriate exceptions here. So let's go into our errors and create a couple more. So the first one is for the user already registered. So user already registered error. And the other one is for the invalid email error. So let's go back in here and say, if the user already exists, raise user errors dot user already registered error. The email you used to register already exists. And if the email is invalid format, invalid email error, the email does not have the right format. Okay, and if neither of those happen, it means the user does not exist and the email is in valid format, so we can register. And then return true at the end. Let's go back into our views and see if everything's done. So what we'll do is register the user, and if that works, it returns true, then we'll add them to the session, which means we can then redirect them to the user alerts. However, if that fails, but does not raise an error, we will eventually send them to the register page. And if that does raise an error, then we're going to return that message, that error message there. So in the next video, let's go into Postman and see if that works. I'll see you there. Hi and welcome back. So in this video, let's verify that we can indeed register. So remember to have your app running and your MongoDB instance running, and then come into Postman and select Post. Enter the URL, so as we know it is this one, 107.0.0.1 user/register. In the body, let's put form data and say email, and then I'm going to put just another sample email, that for example, and then the key, say hashed, and I'm going to paste the same hash as before. So the password here is 123, but it has been hashed as a SHA-512 before being sent to the server. Okay, and then press send. And now we get this is the alerts page, so everything is good. But what we should do is go into a terminal and check that we are indeed here. So this is the one we created before, and this is the one that we created now. Something interesting to realize, and this is the power of key-based hashing, is that these, although they are the same password, are completely different. To unencrypt that, it is very, very difficult. So, brilliant. This works, so we're ready to move on. Thanks for joining me, and I'll see you in the next video. Okay, welcome back. So, let's say we want to buy this camera. This camera is not a particularly cheap camera, so we aren't ready to pay $2,500 for it. If you are, then that's great for you, but I'd rather wait for a lower price. So we want to inspect this price and see how we could make our application get this price from the page. So if we remember, I'm going to bring in another window. This is section 2's program. So if we remember, the way we did it, we got the page using the requests library. And back in the day, we used John Lewis, which is a UK retailer, but we're not going to use Amazon. It doesn't matter what you use. The procedure is always the same. We got the page, then we got the content of the page, we parsed it using Beautiful Soup, and then we found the element that contains the price. Finally, we stripped any white space from before or after the element. We removed the pound sign. Now we can use regular expressions to get the price instead of simply relying on removing the first element. And then we converted that to a float, and then we could use the price for things. Okay. The first thing is to find out how we would find the element's price. So in Amazon, I'm going to right-click the element and inspect. And we can see that there is a span called price block underscore our price. And I've actually gone to other items that are not on sale to see if it's the same. And it is in all items. So this span element has an ID, and an ID is a unique identifier, or at least it should be. If Amazon is doing things right, this will be the only element with this ID. And then it has this two classes as well. Remember, classes are separated by spaces. So this element has two classes, but we're not really worried about the classes. If the ID is unique, which it hopefully will be, then we've got this span here, which will tell us the price of the element. Okay, so what I'm going to do is I'm actually going to copy, edit this HTML, copy that, and then paste it in our code, just so we remember exactly what we're looking for in Amazon, and then we can transfer that to other things as well. Okay, so going back into PyCharm, we've got this endpoint here to load an item. Now, I was actually thinking about this, and I've come to the conclusion that I don't think I need this endpoint at all. I think this endpoint should actually be part of the item model, as opposed to an endpoint that's publicly available. The alert endpoint will call the item load item method inside the item model, but it shouldn't be an endpoint. So I'm going to remove it. If you disagree and you think there should be an endpoint, then by all means keep it, and then you can follow along with that. And then if we go into the item model, then we can create the method called load item. And I like this because self will already have the item's URL, and we can now get the price. So that's what the span looks like for Amazon. And I'm going to make sure that I remember this is Amazon's span only. And items should be agnostic in terms of store. So the item that the way we're gonna load the item is by essentially copying what we did in section 2, and I'm just copying it from another screen and pasting it in here. And as you remember, we are requesting the page, which instead of this page is going to be self.url. Then we're going to get the content. We're going to parse it with Beautiful Soup, and then we're going to find the element. We'll need to import requests, and in order to be able to import requests, we're going to have to add it to the requirements.txt. Sorry, not that, but requests. And I can't remember exactly what version we're working with right now, so I'm going to check that. 2.8. And in section 2 I've just checked we use 2.7.0. So hopefully nothing has changed substantially in this period. And it's actually not been that long a period, so quite quick updating there. Okay, so we'll close that and then it'll prompt us to install, so we can install it. We've already got Beautiful Soup installed, so we can do that. Now we can import requests, and now we are able here to do that. Okay, so the find element takes in two different parameters. The type of tag we're looking for, which in this case is span, and also some attributes, such as the ID or the class. So when we're loading the item, we're going to need a tag name and also a query path. And I'm going to call it query path. You can just call it query. Query might be a better name. Anyway, we need a tag name, which is going to be this. And we're going to need a query, which is nothing other than a Python dictionary, really, a key and a value. And that's how we can find it. So for Amazon, the tag name would be span, the query would be ID is price block hour price. And the store is what will actually be calling this, and the store is what will store these two values. Because for all Amazon items, these two values are going to be the same. Okay, so we'll find that, and then what we will do is get the string price, as we did in the previous section 2, will be element.text.strip, and this will remove the white spaces from the start and the end. And then we can use regular expressions to match the price of the item. So import re at the top for regular expressions, and then we'll say pattern is re.compile, as you remember from the email. And the pattern that we're compiling for is actually /d for digits dot, well, plus /d plus. And what that will give us is a set of numbers dot a set more of numbers. So something like 100.00, for example. And the reason why we're having these brackets is so that we can search throughout the entire string and then find out which element is inside the brackets. So what I mean with this is we will be able to say, for example, for 115.00, we'll be able to say, find me the element that is /d plus dot /d plus, and it will be able to give us 115.00. If we don't include the brackets, then we won't be able to extract the 115.00 from the matching. It'll only be able to give us whether it is there or not, but we won't be able to get it out. So we want to be able to get the numbers out, which is where we'll have to put them in brackets, and that's called a matching group. Okay, and then what we want to do is find out the first group that matches. So in our case, this would be one group, and if we have a pound symbol or a dollar symbol or anything, and then a group like so, we want to find out which one is the first group. Just in case we have something like this, we would only match the first group of them and not the second. So the way to do that is by saying match is pattern dot search, and then we will search the string price. And then we would say self.price is match.group. Okay. And that's us. That would find the group, which is 115.00 in our case, and assign it to self.price. So now it becomes clear that this load item should either be called after the object has been created, so here, or this should be a class method that returns an item with a price already in it. If it is the latter, then we will need to pass it a URL. If it's the former, then we will have to initialize it up here. So we can pick, and neither of the two solutions is very ideal. So it's up to the programmer, in this case, to decide which one of the two to go for. The best option, in order to not have to pass too much data to either of these methods, is probably to give the init method the store in which the item lives. And this store is going to be of type store, and we're going to be able to get the tag name and the query required from the store. So the price is then going to come down here. It's no longer going to be passed as a parameter, and instead we're going to say self load item with tag name is store.get tag name. Query will be store.get query name, and then we'll say tag name query. Sorry, that would not be there. There we go. So store.get tag name or store.get query, they can probably simplify it to tag name and to query, just accessing the properties instead of having methods there. And then we would say self.price is self.load item tag name query. Doesn't really make a lot of sense. That load item is returning a price, so we're going to change load item to load price, and then down here at the bottom press do refactor, and that will change the method name. And instead of assigning the price, we're going to simply return match.group, and that's going to return the price, which we are then going to put into self.price. Okay, so reasonably complex creation here, but I think it's still understandable what we're doing. We're setting the item's name, URL, and the store that it lives in, and then that's allowing us to get the tag name and the query, which we are then passing in order to load the price of the item. Now when we're in the store will be able to give us items that live inside the store, but we'll do that in the next video. So this is how we would load the price of an item inside Amazon, and I'm going to remove that comment because it no longer makes sense to have it there. This will let us load the price of any item as long as the tag name and the query make sense for that URL. Okay, so next up, let's try to work with saving these into the database, and then we'll go and move on to the stores. I'll see you there. Hi and welcome back. So saving to database is actually exactly the same as with the user. Simply save to Mongo, which will return, well, rather insert into the database the JSON representation of this object. So you'll need a JSON method that returns a dictionary, which is the JSON representation of the current object. But I won't bore you implementing that just now. I'll let you do it, and then I'll fill it in myself as well, and we can go over it after that. So pause the video, try to do that yourselves. It will be fairly straightforward. You can look back in the user model if you are unsure, and then resume, and we will continue from there. Okay, so easy enough. Save to Mongo simply does database.insert item constants not collection, and I've created that file and I've imported it up here. Import source.models.items.constants as items constants, and then the self.json is what we are writing, and that simply returns the name and the URL of the item. The constants file contains the collection equals items. Anyway, so that's how you would save to MongoDB. Retrieving from MongoDB would also be the same as from the user, and as we did in the last section, simply from Mongo and then database.find by name. So doing that, I'll leave to you, but in the next video we're going to move on to the stores, and then we're going to be able to practice and verify that this actually works. So I'll see you in the next video. Hi and welcome back. So here we've got our store class, but now we know that the store needs some more data as well as the name and the URL prefix. The name is simply so we know what type of store it is, what store it is in fact. The URL prefix was going to be used so we could match URLs to the different stores. For example, if a customer gives us a URL that starts with www.amazon.com, we'll know how to parse that based on the fact that it is Amazon. And then we'll have the tag name and the query, which are used for searching the items in that store. Okay, so now we've got the data stored in the store object. We can go back into the item and verify it. Now we can go to Tools, Python Console, and we can create an item and see if the price gets found properly or not. So what to do first is import the two models that we need, the item and the store. And now we can create a new item. So the item's name is going to be a Canon EOS 5D. The URL is going to be here. And then the store is the object that is passed as the third parameter. That takes in a name, a URL prefix, which doesn't matter just now because we're not using it. It also takes the tag name, which we know is span, and it also takes the query, which we know is ID is price block hour price. So quite a long constructor for the item here, quite a long initializer. And when we present it, we're going to get an error because Amazon is too smart, too closed. I'm not sure what the correct word is, but essentially Amazon does not let you do this. You need to sign up for their API and to their partner program in order to be able to use automated calls like so. So we can't do this with Amazon. Well, truth is, it doesn't matter because we can do it with any other store. So if we go back into the store that we selected in section 2, and what I'm going to do is press the up arrow, and that's going to bring the same line that I just wrote, and I'm going to change the URL for the one in the section 2, and I'm going to change the query as well to the John Lewis query. This would be saved somewhere in a database. I'm going to change these names as well just for the sake of it. And then I press enter. And there we go. Now we've got the item and we know the price has been loaded because it has not failed. But what I'm going to do is I'm going to copy that and assign it to a variable so that we can check the price. And voila, the price is still £115. And if you guys remember from section 2, the price was still £115, and I ended up buying that chair for £115. So I never got a discount on it, unfortunately. I am making them some marketing efforts here, so they could give me something, but they didn't. So there you go. It failed in Amazon, but it didn't matter because the way we've designed the program to work will work in any store. So if Amazon needs us to sign up to their affiliate program or whatever it is they need, then we can do that. But the point being, it works in other stores. So if another store that we're interested in, we can do it with our program. Okay, so next up is going to be actually saving these stores to the database and being able to find them through the URL. So we're going to do that in the next video. I'll see you there.
Okay, so before we continue, let's remember that we have to include the underscore ID in the constructor and in the attributes of the object so that we can save them to the database without using MongoDB's object ID by default. That is because if we use the object ID, we won't be able to retrieve the elements very easily from MongoDB, and we won't be able to search through ID very easily either. So let's just add that in. And if we remember, we've got that already in our user. So I'm opening the user file here, and we've got the underscore ID equals none, and then we're generating an UUID4 if the ID is none. And if the ID is not none, we're using the ID that we're passing in. So when we retrieve the user from the database, we're going to use the ID that's in the database. And if not, we're going to be generating one. And we're going to do the same for items and stores, and indeed the alerts as well. So I'm going to go into the item, and simply say underscore ID is none. And then at the end here, self._ID is UUID4.hex if underscore ID is none, else underscore ID. And we're going to have to import UUID. And I'm just going to copy that and paste it here in the store, remembering, of course, to say that there as well. And when we come to using the alerts, which we will soon, we will also put that here, but we might as well just do it now. So underscore ID is none, and then this gets pasted there as well, and we need to import UUID. and we'll need to import UID in the store as well. Okay, so now we've got these IDs being generated for the items, so we're no longer going to be using the MongoDB object IDs. In order to make sure that we are doing this, we're going to need to change the self.json methods as well. So instead of name and URL, we're also going to put here ID is self._ID. We're going to go into and put a comma at the end, of course. Go into the store, and when we get to save them, which we're going to do in the next video, we'll do that in the JSON, and in the alert, we'll do that in the JSON as well. So we're going to make sure that we're putting the _ID in the correct places, so MongoDB doesn't generate one for us. Okay, so now let's move on to actually saving the stores into the database and retrieving them with a URL. And for that, we're going to need to learn a bit about how we can do a regular expression search on MongoDB. I'll see you in the next video. Hi and welcome back. So in this video, we're going to be saving our stores into the database and also using the stores that are saved in the database to get item prices just by putting the item URL. So the first thing we have to do is to essentially get the JSON of the store. So I'm going to define the JSON method first. And this is what data we're going to be putting into the database related to this store. So it's going to be the ID. And that's just self.id. It's going to be the store name, which may be something like Amazon or John Lewis or whatever it is that we're putting in. And that's going to be self.name. It's going to be the URL prefix. And this, as we know, is what does the URL start with for this store. So this is going to let us search how to get the item price, how to parse the HTML, depending on the URL that they give us. So this URL prefix. And then what we're going to do here is simply say self.URL prefix, the tag name, which we're going to need to parse the HTML again, as we've seen before. And this is going to be self.tagName. And finally, the query, which is what attributes and properties does that element, that HTML element have, that tag, that is going to allow us to narrow the search down to one specific tag and not simply all of the tags that are in the page with that name. So this is going to be self.query. Okay. Then we're going to be able to get the store by ID. So this is simply going to be the ID. And what we're going to do is return a CLS. So this is going to be a class method. And instead of self, this is going to be CLS. We're going to return a CLS of the unmapping or the unpacking of database dot find one store constants dot collection. And this is I'm simply doing exactly what we did for the items before. So even though these things are not imported, I'm just going to import them in a moment. And the _ID is going to be the ID that we're passing in. And now we can go and import these. That's the one. And because we're using as to import this, this is not the name of the module we're importing. We're renaming the module on import. PyCharm won't let us do that through IntelliSense. We're going to have to do it manually. So we'll do import src.models.stores.constants as store constants. And we're going to go into the stores and create that file, and it's simply going to contain the collection. Like that. So exactly the same as what we did with the items. Okay, and PyCharm kind of warns us that we're importing a module that starts with a lowercase as a non-lowercase. So it tells us that may be confusing to some people, but we know what we're doing here. We know that we're renaming this module, and I like the fact that I'm accessing the variables in the module like that. I like that store constants dot collection. It kind of tells me that this collection is part of the stored constants, and and not simply of a module called constants. So I'm going to stay with that, even though PyCharm was warning me. We can choose to ignore those warnings. Although sometimes, and in fact many times, PyCharm is right and we should follow the warnings. Okay, so save to Mongo is going to be another method that we're going to want to create in order to save the store to MongoDB. So that's only going to do database.insert, store constants.collection, and then self.json. As we know, we've done this plenty of times now. And then we're going to create a class method to get a store by name. And this is going to allow us, well, to allow the user rather, to search the stores that we have in our database through their name. So this simply takes as a parameter the store name. And what it does is it returns CLS of the unpacking of database.find1 for source const.collection, and then the name is the store name. So I think that kind of makes sense. We're simply finding one store called whatever we pass this method. We're unpacking those values and passing them to CLS. Now what that does is create a store object, which is what we're defining here in this class. And finally, the important one is the getByURL prefix. So another class method, getByURL prefix. And what this is going to do is it's going to allow users to give us the item URL, and then we're going to be able to tell them what store that URL belongs to. So for example, if they give us something like http://www.johnlewis, we will know that this belongs to johnlewis.com. And in fact, if we only have one store in our database, they can give us that, and we'll know that belongs to that, because it's the only store we've got. If they give us that, we'll also know it's that. If we've got two stores, and they give us that, then we won't be able to make that assumption, because it may be the other store. So this is going to allow us to search. So basically what we're doing is we're matching whether the two strings begin the same way. So return CLS, the unpacking database.find1 for that collection, and then what we're doing is saying URL prefix begins with these characters here. And the way we do that in MongoDB is by using the $regex operator. So what I'm doing is saying URL prefix is a regular expression, which we know how to do. And a regular expression, the start of the string is marked with one of those circumflex tildes, I think they are called. So we're going to do that, .format URL prefix. Okay, so what is happening? As we know, this and that .format URL prefix will simply replace URL prefix into that string. So we're going to get tilde http://www. blah blah blah. And then we're saying that is a regular expression. So that's this dictionary there. And then we're saying URL prefix is going to match with that regular expression. So what that is going to do is it's going to allow us to say, when we give it http://www.johnlewis, we're going to be able to say, okay, this is the store that has underscore ID, blah, 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 and name John Lewis, etc. And then that is also going to contain the query and the tag name, which we're going to be able to use to find the item price. So this is what this method is going to do. Okay, so how is it going to work? How is the user going to interact with this method? How is our application going to interact with it? The application is going to the user is going to start typing, or the user is going to send us the URL. So say the user has something like http://www.johnlewis.com/item. I know the URLs don't look like this, but and then it's got some sort of ID, and then it's got .html. For example, say they send us that URL. What we would do is we'd say, okay, H, does that match something? Probably not. HT, does that match something? Probably not. HTTP, does that match something? Probably not. Because we are going to have more stores, so HTTP is not really going to match anything, but we're still going to do those queries anyway. And then we're going to keep doing that. I know you guys can't see very well that, sorry. Until we get to something like http www.john. And then is that going to match something? Probably yes. And that's going to match a store object, which is going to be the John Lewis object that's going to come from the database from that unpacking and that CLS. So potentially this will be as short as that. If we only have one store that starts with a J, then as soon as we get to this J point, we're going to say, okay, we've got John Lewis, so that's the store we're going to return. But if not, eventually you'll get to something like this, and then we'll return it, or something like this, and then it will return it. What is important is that the URL prefix of the store is defined well. So if this is the URL prefix of John Lewis, if all of John Lewis's URLs start with that, then we're going to be able to match them when the user gives us a URL. Okay, so that's enough for this video. Hopefully that kind of makes sense, and that's how this is going to go. So when the user sends us the item URL, we're going to do all these steps, start from H, then the next character, and then 3 characters, and then 4, and so on, until we match something. And if we get to the end of the string without matching anything, then we've got another problem. All right. So this is getting now interesting and getting a bit more complex, but hopefully you're following along well and all is making sense. So until then, and I'll see you in the next video. Welcome back. So in this video, we're just going to be verifying that all of that works and showing you how we can check that. So I'm going to delete this comment here because now we know what this is going to do, so we no longer need it. And as we know, a lot of comments will end up cluttering your program. And another problem with comments is as you update your program and you forget to update your comments, eventually your comments start showing incorrect information. And we don't want that. So when a comment is essential and necessary to understand your code, put it in. If it's not necessary to understand your code, don't put it in. Okay, so let's go into our tools in PyCharm and then open Python console. Depending on which PyCharm you're using, you may see more or less options here. So open up Python console, and what this brings up is the Python instance that's running in your virtual environment. So this contains all the libraries that we're using as well as, basically everything that we've installed for this project that is running on the virtual environment set up for this project. So here we can do from src.common.database import database. And we'll say database.initialize. And I've got my MongoDB instance running in the background. So this is why this works. If you don't have it running, then this will fail. And then what we'll say is from src.models.stores.store import store. And that's going to import the class that we are just writing. And here we can say store is a new store, which is going to be called John Lewis. The URL prefix is http://www.johnlewis.com. And what this means is all of John Lewis's pages, all of the items, start with this URL. If they started with com/items, then I would put that in. Okay. And then we need the tag name, which is, as we remember, is span. And then we need the query, which is item prop is price, and class is now dash price. Okay, so now we have the store created. And if we type store, then we get back this representation here. Okay. So now what I'm going to do is I'm going to say store.save to Mongo. And that's going to save it to MongoDB. And then I'm going to say capital store, which is the class, get my URL prefix. And then I'm going to say http://www.john. And notice that we get store John Lewis back. We have matched this to the John Lewis store that is saved in the database. Okay, So now we know this works, and the next thing we have to do is ensure that we can, from this, make sure we get an item back successfully. So we have to be able to say, store, give me this item with this URL, and then we'll parse that item's URL with this store's details. Let's do that in the next video. All right, welcome back, and let's try to get our stores to be able to give us the information necessary alongside our items to complete this flow that we've got here that's slightly incomplete right now. So this method that is going to allow us to give our stores a URL, an entire URL, and then we're going to be able to find a store from that URL, we need to put it here. So I'm going to create another class method, and I know you guys can't see this very well because it's a bit low down, but sorry about that. And I'm going to call it find by URL. And it's going to take an entire URL. So the items URL is going to come in here, and it's not going to be just the prefix. So this is going to return a store from a URL like http://www.johnlewis.com/item/ a few numbers .html. So we're going to give it a URL like that, and we are going to be able to start at the H, then HT, then HTT, and so on until we match a store. And if we get to the end of the URL and we haven't matched the store, we're going to return an error. So the items URL is the parameter, and it returns a store or raises a store not found exception if no store matches the URL. Okay, so I think that makes sense. And the way we're going to do it is simply start in character number 0, move all the way up to character number length of the string. So for I, for our index, in range from 0 to the length of the URL. Sorry, I don't know what happened there. And there we go. And then we're going to say the store is cls.getByURLPrefix. And the URL prefix we're going to give it is URL open square bracket :I. Okay, so why? Why am I doing that? If you remember the lecture on slicing that we did way back in section 1 or 2, I'm not entirely sure which one of the two it was, you'll know what this means. But just in case, we're going to open up IDLE, which is our Python shell, and this is a very useful tool. You should have it open when you're developing, just in case you want to check something. So I'm going to create a string called 12345, called s with that value, and then what I'm going to do is s open bracket :1. And if you remember the lecture on slicing, this takes us from the value before the colon, which by default is 0. So it takes us from 0 to 1. So this should only give us the number 1. Okay, so that does. And if we say s from :2, this should give us 1 and 2, and it does. So if we say I is 4, and then we say that should give us the first 4 characters, which it does. So now you can see why we're doing this. So if we say for I in range 0 length of s, say print s I, it gives us 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. Okay, so it's good that we checked because we found a small bug, which is we've missed the last 5. So what we want to do is copy this, paste it in here, and say length of the string +1. And then that would give us all of them. So we go back into our program and say from 0 to length of the URL +1. Okay, so now we're going from the first character, the H, all the way to HT, then HTT, then HTTP, and so on, until we get to the very end. Remember that even though I increments, so at first it's 0, then it's 1, we're not only getting the character with the index I. So we're not only getting character number 0, or not only getting character number 1, but we're getting up to that character. Okay, so remember, getByURLPrefix will return the store if it's found, or it will raise an exception if it does not find a store, because then this will be none. So if we don't find anything, it will break. So we have to say try to do this, and if we have an exception occur, then simply return none. And here return store. So what we'll say is get the store without URL prefix, and if that raises an exception, which it will if it doesn't find anything, then return none. And if it doesn't break, it means we found something, so we can return the store that we found. Okay. However, return none is a default for all Python methods. So all Python methods return none if we don't say return something else. So we can simply say pass. Pass doesn't do anything, so it will do nothing, and then it will return none anyway, because that's what Python methods do by default. Okay, and instead of pass, which will return none, what we can say is tell the user or tell the program a bit more information. So raise another type of exception. So we're going to raise store errors dot store not found exception, and we're going to have to create this and give it a message like the URL prefix used to find the store didn't give us any results. And then we'll go into the stores here in the store package, create a new Python file called errors, and then simply say class store exception, subclassing from exception, and then find the init method that accepts a message, and then say self.message equals message, and then class store not found exception, subclasses from store exception, and doesn't do anything. And that way it will just inherit that same constructor. So now we have to import store errors. So I'm gonna come here and say import src.models.stores.errors as store errors. And now that will work like that. Okay, notice how we've got an importing of item here that's in gray, and we're no longer using item here, so we can just delete that. So now we need to go into the item itself and say, we were passing a store to you, but we no longer have to do that because we've got the URL. And with this URL, we can find the store. So we no longer have to pass it a store object. What we can say is store equals store dot find by URL, and just pass it the URL of the item. And now that will means that we no longer have to pass the store in, which we weren't doing anyway. And now we can find it by the URL. So what do I mean we weren't doing that? As you can see, we have the store as a parameter, but the self.json method wasn't actually saving the store into the database at all. So when we load items from the database, we were actually not going to be able to do it properly because we would be missing a parameter in there. Okay, so we'll get to that later on. Now we've got that, we can go into our tools and run the Python console and then find out the price of our item. So let's do that first. The only thing we have to do is, first of all, initialize our database from src.common.database import database, database.initialize, and then import the item from src.models.items.item import item, and now simply say I, which is my item variable name, is item, the chair name, doesn't matter what you call it, can be anything, and then the URL, which I've got pasted here. And now I.price is 115, which is what is in the website right now. So what has happened? Because this is starting to look like magic to me. And I'm surely to anybody who uses this, it will also look like magic, because what's happening here is we've given it a URL and suddenly we've got the price of the item, and the number of things we can do with that is quite surprising. So what happened here is we've simply given our item a name and a URL, so we've stored those for later use, and then we've found the store with that URL. So what that's doing is starting from the first letter of the store URL and then matching with regular expression all the stores in the database that start with that. eventually when it finds one, it gives us back a store object, and that object contains the tag name and the query, both of which are used to load the price of the item. So we're parsing the HTML content of the page, and we're using that tag name and that query to find the specific element that contains this regular expression pattern here, and number.number, which is 115.00, for example. So we're matching that pattern, and that's giving us the price of the item. Woof. So now that we've got the item prices, and we don't really have to do anything, and that's a great thing. Once we created the store and it's in the database, we can just ask for items by giving them the URL, and that's it. We could optionally extend this program so that stores has two queries and tag names, one to find the item names and another one to find the item prices. Our program doesn't do that, so we have to give the name ourselves, but potentially if we allowed the store to find item names as well, which would just be the same thing, only with a different tag and a different query, we could actually skip the name as well, and we would find it through the HTML content too. So if you feel courageous, then go ahead and try and do that. That would be a really nice thing to advance your knowledge with. Okay, so now we can do that, and we can actually move on now and start working on our alerts. So, cool stuff, and see you in the next video. Hi and welcome back. So in this video, we're going to be discussing how we can start making our alerts, and we're going to see how we can send emails using Python. Now there are two main ways to send emails using Python. One of them is using a library that's built into Python called smtplib, SMTP being the standard protocol for sending email messages. The problem with using smtplib is that you need your own SMTP server, you need your own email server that can send those emails over the internet. So the only thing you would be doing if you use that library is tell your email server to send an email with some parameters, such as who the email is coming from and who is it to, subject and text, and so on. So that's all good, and that's actually the way I would do it if I had my own SMTP server. For example, at work, we have our own server, and then we send emails using that method, and it all works fine. And it's very safe, because your email data stays in your own server. You send the email over the internet, which is maybe not as safe, but that's fine. You don't have to use a third party. However, for us, we're just starting, and we don't have our own server. In some cases, you may want to use your Gmail account to send emails, but if you're developing a service, that may not be the best solution. So if you're developing an application, using a Gmail address may not be the most professional way to do it. So what you can do is sign up to Mailgun, and Mailgun is free when you're starting. As you can see, 10,000 free emails per month. You don't need a credit card, so you can use this. And sending an email using Mailgun is very easy. This is actually all of the code you need to send an email through Mailgun. So what we're going to do is I'm going to give you a textual way, like a text file that describes how you can send emails using smtplib, and it's fairly simple. But in the videos, we're going to be using Mailgun, simply because it makes sense from a practical point of view. So if we copy this, just the request.post onwards, we don't want to create the method. So if you simply copy that, and then go into your PyCharm, and then go to Tools and open a Python console, and then simply say import requests, and then paste that in, and in the to field, put your own email. So in here, I would put my email, and then go to the end, and simply press enter. And in a moment, I'll be getting an email from this account. So you should try that and see if all that works. You'll be getting an email from this excited user at this email address. And the way this works is it's simply using the Mailgun public API. So they've got this API here that allows us to send some data to it, and the data that we're sending is from, to, subject, and the text. So that's the data that's going to compose the email. and we have to authenticate, we have to log in, and the way we log in is using an API key. So whenever you register into Mailgun, they will generate an API key for you, and that's the key that you need whenever you're requesting things from their API. The key is unique to you, and the key that we have here is a sample key that they give us so we can test it out. So what to do is go into Mailgun and register, and then we'll start using the Mailgun service to create our alerts. So I'll see you in the next video. When you're registering for Mailgun, remember that you will need your own domain name if you want to send large amounts of emails. However, they give you a sandbox server that you can use to send up to 300 emails per day, which is quite a lot for testing purposes. So when you're making your applications, you can always use the sandbox server to send emails, and later on, when we get to giving them to our users and deploying them to be live, we can then register a domain name and use that with Mailgun. But for now, don't worry about getting a domain name. Simply use the sandbox server that they give you when you first register. That way we can send up to 300 emails per day, which, as I said, is plenty. So in order to access your sandbox domain through which you can send your emails, simply log into your Mailgun account and then go to Domains. Your active domain will be the sandbox domain. When you click on it, then you will be received with the information that you need to send out the data. So these are blurred out because you shouldn't be sharing these with anybody. Okay, so this is all you need to send emails, and you can, using this, send emails to your own email account for testing purposes while you develop the application. And after that, you'll have to purchase a domain name and use that domain name to send emails to your users once your application has been made and deployed and everything. But until then, you can use this for free